Hello, my name's Andy Reed. In this video I will review many concrete materials for quantity, counting and arithmetic. But first, a word of warning. Some things which are described as concrete are not concrete. Here's an example. Please don't use this sort of thing, illustrative and symbolic or written, until you're sure that with speaking the child understands the quantities. Here's another example. Although this is a hands-on activity that's taking the numbers out and putting them in the right place, they are symbols or written figures for quantities which the child may not yet appreciate. Please don't use that at the beginning. I find a sock with objects a very handy thing at the beginning. In it are the number of objects which the child at the moment can count, so the child can empty it at any time and practice with someone else, grandparents, parents, sisters and brothers, how far the child can count. And if the child learns more, it can take more, as many as it needs, and carries the sock around with it. If it's a small sock, you need a clip. If it's a large sock, then you can just tie a knot in it. Any objects will do, as long as they're the same: cubes, bottle tops, triangles, and so on. These are known as the Cuisenaire rods, though they do have other names, and they are rods with units of 1 up to 10. Suitable for very simple work at a low level and not very suitable for much more. You can do a little bit of counting with it and some adding and subtraction. They are not very suitable for the activities that I am going to show. If you have it, then try and use it a little. If you don't have it, don't bother. Here are the Numicom shapes from 1 to 10. They are based on pairing, as you see, and this is a serious disadvantage because you can't compare length, and also they have set shapes for each quantity, so the variability is not there. As multiplication is based on the rectangle, it is not easy to simulate multiplication with these shapes. There is also a square 100 available with pegs to fill in, and you can do some work on multiplication, but it is limited. Although they are nicely produced, I cannot recommend them unless you already possess them, and then you can use them for some of the activities which I show on my video. This here is the Dean's apparatus. It has a 1, a 10, 100 and 1,000. Again, multiplication is based on the rectangle, so you cannot use the 1,000 for multiplication. The unit, which is a 1, is a small cube and is rather small, but it's possible to use by the children. You can use this for a lot of the activities I show in my videos, but not for all of them. Here I have the bead apparatus from Maria Montessori. It is based on the same principles, as you can see. There is the 1, the 10, the 100 and the 1,000. The bead is very small and quite difficult for small hands, although you can buy a larger scale version of this. The 10 is held together with metal. If you join them together, you have produced an untrue length because you're adding in the small hooks at the end. So this is a disadvantage as well. And like the Dean's apparatus, you cannot properly multiply with it. Maria Montessori saw this disadvantage and invented the so-called chessboard for multiplication, which in itself is mathematically correct, but it is a trick which the children have to learn and something that they didn't think themselves. If you have the bead apparatus, you can use it for many of my activities but not for all of them. Otherwise, I do not recommend buying it. I thought there had to be a better set of concrete materials for the covering comprehensively of quantity, counting and arithmetic. I tried lots of alternatives and landed on compressed wood with the holes already in. This is packing material, and I was able to produce the 1, the strip 10 and the square 100. And with the use of marbles, I was able to think out lots of impulse activities and comprehensively cover all the aspects. However, it has a few practical difficulties. One is that it's rather large, and the other is that when you saw it, you lose 4 or 5 millimeters of wood, and therefore the result is not geometrically true. If you want it geometrically true, you have to do a lot more sawing and there's a lot more waste. I moved on to PVC, which I find to be a much better version, and one great advantage is that all the holes have a square boundary which is raised, so that when the child takes a marble and puts it anywhere near the hole, it automatically rolls into the hole. So it has another advantage. It is concrete materials with the marbles, and the Mathy Mats on their own are also a concrete approach. With the marbles and the Mathy Mats and dice, I can also cover stochastic, some graph work and probability. Here are 3 alternatives where you can produce your own. One is based on the bottle top, which I modelled for use in Uganda. This is the 10 and this is the 100. You can do quite a lot of my activities using this, but it does have some limitations. Also, you can set out particular patterns as a challenge for the children, and you'll be seeing those in some of my videos. Alternatively, you can go to click bricks or click cubes, as they're sometimes called. Either you take a 10 with just one colour, or you have 2 colours so that it's easier to see. By the way, you can also buy a larger version of these bricks, or you can use Lego bricks. Again, either a 1 colour version of the 10 or a 2 colour version, so it is easier to see. For early counting, it is also possible to make your own concrete resources. You need a supply of egg boxes which contain 10 eggs, and then you cut them in half like this, so that you then put them together and make some holes with a small sharp object, and you can join them with these paper clips, and you come up with something like this. That's a 5er, and therefore you can join them together to make 10 or 15 or 20, as far as you wish to go. And then counting with the children, we count how many objects are in there. There are none, and then 1, 2, 3, 4, 5, 6, and so on, as far as the children wants to go. Dice are wonderful hands-on materials, but they are, strictly speaking, not concrete resources. I use them a lot and I am a great fan, and the children adore using them. I have, first of all, the dotted dice, 1 to 6, absolutely normal. I have a 6-sided which only has the quantities 2 and 6. I have a dice which only has the quantity 5. This dice is irregular, and the children like it, along with these other joke dice, and has 1 to 6. This has 0 to 9, and this has 1 to 12. When the children have a good grasp of quantity, we can move on to the dice with numbers. There's 1 to 12, 1 to 20, 1 to 24, and 1 to 30. And last of all, there are the base 10 dice, very, very helpful. There's the 0 to 9, the 0 to 90, the 0 to 100, and so on. I'm a great fan of dice, and the children adore using them. There's lots you can do with them, and apart from using them in many of my activities on my videos, there will be a special video concentrating on just the use of dice. For the transfer from concrete to illustrative and from illustrative to written, I use a very simple 1 centimetre grid. I have several special versions of it. There's the version for the square 100, very helpful at the beginning because the children take too long to do it themselves. I also have a special version for some of the impulse activities, in this case for games. What's very important about the square 100 grid is that I require children to only write one symbol in each square. This eliminates a lot of problems and produces very ordered writing, and that's very important for mathematics. Well, that's all for this video. I hope you enjoyed it and got lots of tips. Why not go to my website to find out all the links, the downloads of the tables, for instance, and information. And why not subscribe, and then you'll get the latest information.